Hi guys, welcome to Linux YouTube channel. My name is Ram Mishra and I'm your online instructor. So what's in this video? In this video we will talk about Kubernetes Persistent Volume. But before start the lab session, we need to understand few points, which is what is Kubernetes Persistent Volume and their use cases. So we know very well that Kubernetes is useful tool for deploying and managing containerized application. Applications deployed on Kubernetes are often stateless, meaning that the application do not rely on any previously saved data in the cluster to function properly. However, there are scenarios where you need to deploy application that collect and store the data that must be always available even when you terminate the pod. So this is where Kubernetes Persistent Volume come in the picture. So this is the official documentation. You can read more information from there. Kubernetes Persistent Volume provide persistent storage for your containerized application. Even after restarting, the application pod will still have access to the previously stored data. One of the most important functionality of Persistent Volume is providing storage beyond the lifecycle of a pod. Some use cases for persistent volume include providing storage for database application, storage beyond the regular pod lifecycle, storage for storing application log, storage for storing user generated files in the content management application, and so on. So in this demo, what we are going to do, we will explore Kubernetes Persistent Volume and including some relevant use cases and how they can be effectively set up and used. We will understand from one scenario, we will create persistent volume claim, and then we will use them in a pod. We will create index.html file and mount it using host path, and then we will mount the same PVC to different pod and we'll try to find the same file on the second pod, and we'll check the data also. So let's begin the lab session. So here the things are there, what is PV and PVC, right? So I'm back on my VM. Let me log in first. Okay, so currently I'm working on single Linux machine where I have already installed Minikube single node Kubernetes cluster. Let me show you the OS release version of this machine and Minikube status. So if I go back with the K8s etc Red Hat release, you can see it's 9.3 and Minikube status. So yeah, it is up and running, and let me check the node status using kubectl get nodes. Okay, it is ready, as well as the pod. Okay, currently I don't have no running pod available in this machine, right? So let's move to the first tab, which is demonstrate a pod with no persistent storage. Let's see what happens if I don't go with the persistent storage, right? So let me create a simple nginx pod by running kubectl apply hyphen I don't have a file, so let me go with kubectl run first pod hyphen image. What image I want to go with? Nginx. Okay, first pod created. Let's check the status hyphen o void. Let me go with watch container creating. Okay, so this pod has one container and no permanent storage, right? No persistent storage. We will execute into the container, and we will try to make some file, and let's see what happens. So let it be complete first. Okay, it's running. Now let me move with kubectl execute first pod hyphen it hyphen bash. I need a shell. Okay, I'm in the container, and we create a file in usr share nginx html, right? So usr share nginx html, this is the folder in which nginx web server normally keeps its index.html file. Let me make a file index.html. Hi, this is demo web page. Okay, control C, index.html, yeah, it is there. Let me exist. Okay, so let me hit to try to this web page from my Kubernetes minicode node, right? So what is the IP address? IP address is 10.244.0.7. okay, so I can go with minikube ssh curl. IP address is 10.244.0.7. so if I try to hit, see, I'm getting my custom web page, right? So let's remove this pod and let's recreate it, and let's check what happened with this custom web page. So if you want to delete kubectl, delete pod, pod name first pod, deleted. Okay, let's see. No, I don't have any pod, and we recreate the pod using the same earlier command with different pod name. So I'll go one more time with the second pod, nginx, nginx, and pod name is this time second, second. Okay, done. So continue creating. Okay, running. Now let me try to hit one more time on the IP addresses. Earlier I'm trying to hit on 244.0.7. Let me go with 20048. Let me check, did I get the same web page? No, I'm not. See, this is welcome to nginx default web page. So as you can see, when we hit to the container web page, the content of index.html that we have created is no longer present. So the question is, how can we make sure that the file does not disappear after pod restart? You will not want to recreate your website or database every time you delete a pod. The way to solve this problem is leverage with persistent volume. They are called persistent because they persist even if the pod are deleted, restarted, or recreated. So let's delete this pod again and move to the persistent volume concept, right? So you can remove this one by delete pod, pod name, second pod, gone, everything is gone. Okay, now move to the second part, which is make persistent volume. So the code for making persistent volume is available on Kubernetes documentation. You can grab it from there. Let me show you where it is. So go with the official documentation, and if I scroll down, uh, here, this is what, this is pod YAML file and persistent volume. Okay, yeah, here it is. How to create, here's the code, right? So you can see the code is there. API version 1, kind, metadata, storage class, and you can go with that one, right? So I have already copied this code and made the changes as per my needed. So let me copy from my notepad. So let me copy this one. I am back on my machine, pv.yaml. Let me copy and paste it, and now let me try to explain this one, right? So here is a simple manifest file for the persistent volume. This YAML configuration file specifies that the volume is at mnt data, volume path is mnt data on the cluster node. The configuration also defined a storage of 10 gigabit in size of the volume, right? And access mode of read write once. This is the access mode. Read write once means the volume can be mounted as read write by a single node. The configuration file also defines the persistent volume storage class name. So in my case, this is local storage. It could be anything, right? So my file is ready to let it be deploy. But before going to deploy, let's see the status of available physical volume or persistent volume. So you can go with kubectl get pv. Okay, see, currently no resources are there, right? So let me deploy using kubectl apply -f pv.yaml. Now going back, pv, see, it's available. So here you can see the above command will show the persistent volume status as available, which means persistent volume is yet to be bound to a persistent volume claim. Now that the volume has been deployed, we can deploy our claim. So in the next, what we need to do, we need to create a persistent volume claim to request the persistent volume we have created. So move to the next step, which is create persistent volume claim. Persistent volume claim is a request for storage by user. It is similar to a pod. Pod consume node resources and PVC consume PV. Pod can request specified level of resources like CPU, memory, and claim can request specified size and access mode. They can be mounted read write once or read only many or read write many. More information for related this one, you can go over the documentation, right? PVC will bind to persistent volume if it match the access mode and storage class name that we have defined in the file. So in our specified case, access mode is read write once and the storage class name is local storage. So we have to be remember very careful about this name, right? Now let me go with pvc.yaml file. So pvc persistent volume claim.yaml, sorry, YAML. Let me go back again on my notepad file. The code is still available in documentation, you can grab it from there. I'll save it. So my simple pvc.yaml file is ready. So here is my persistent volume claim configuration file that requests a volume of at least 3 gigabit in size and can allow read write access for at least one node. So let me deploy this file using kubectl apply command. So I save it, kubectl apply -f pvc.yaml. Okay, now once your claim has been created, we can look for those claims by using kubectl get pvc. Okay, here it is, bound. Okay, let me go with both pv and pvc. Okay, so here you can see, perfect. Let me make it large for you. Okay, so the volume is set up and claim ready to be used. Now we can deploy our pod and services. After running this command, the Kubernetes control plane will look for a persistent volume that specify the claim requirement. Suppose the control plane finds a suitable persistent volume with the same storage class, it binds the claim to the persistent volume. As shown here, the status indicate bound state. See, it's bound. That means PVC and PV are now bounded together. We now have both persistent volume and persistent volume claim. But question is, how do we leverage them in a pod? We cannot simply type kubectl run nginx or first pod or second pod and image is equal to nginx, as the pod will not know anything about underlying storage. So for this we will need to use another YAML file to create our pod file with this volume. So now move to the next step, which is create pod that will leverage our PVC for persistent storage. So let me go to the last YAML file. This is the pod.yaml file. Let me copy and make my pod.yaml file. Currently I don't have any pod. Okay, let me save. So here I had created a pod file, pod.yaml, with the name of first pod, with the mount point is usr share nginx html, right? And the host mnt data and the mount point is usr share nginx html of container, and the host mnt data mount intend to be mapped in the usr share nginx html path in the container. So looking at the above configuration file, you would notice that it specifies the persistent volume claim, not persistent volume. Here you can see persistent volume claim, not volume. This is because the claim is a volume formed from the pod perspective. So in the pod declaration YAML file, note the volume section under the spec, we are instructing the pod to use PVC that we have created earlier, right? And the name is storage, right? And in the container section of the declaration, with the use of volume mount, here we have used usr share nginx. We are telling the pod to be mount that storage usr share nginx html, right? And the claim name is pvc claim, right? So this YAML file launch one nginx container with persistent volume. So let's save the file and deploy. Okay, kubectl apply -f pod.yaml. Let me check the status of my pod. So going back, yeah, it's up and running condition. Now we need to confirm that the pod has been configured to use the host path persistent volume as storage from the persistent volume claim. So to test and confirm to the configuration, you verify the nginx service serving the index.html file from host path volume or not. So let me make index.html file on cluster node on host volume first. Let me move to the minikube SSH. Let me make sudo privileges. I'll move to the mnt data here and let me make a file. This is web page from minikube node. Okay, that's sufficient for testing purpose, and make the file index.html exist and exist. Perfect. Now let me log into the nginx container and check the web page. So kubectl, the earlier we ran the exe command, if you remember that one. Let me show you where it is. Kubectl exec first pod bin bash. I'm here, and let me update the package and install curl command first. So apt get update. Okay, let it be update, and then we will install apt install curl command to get the curl command. Apt get install curl. Done. Now run the curl localhost. Yeah, you can see this is the web page from minikube node. Okay, so we will get the output of my index.html file which we wrote on host path volume on minikube node. Remember that one. Let me try to make some new file here also. So where I am usr share nginx html. Okay, file is there, and let me try to make few more blank file say 1 to 10.txt. Perfect, I have created 10 more blank file. Let me exit from there. So I created 10 more blank file. Let me check the content from the host path volume from minikube node. So I can run minikube ssh ls mnt data. See, I got the files as well as index.html both. So even if the pod is dies or restart upon recreation, it will have access to the same storage. Let's try it. Let me delete the pod. Kubectl delete -f pod.yml. Okay, let me check the pod. See, I don't have pod. Let me try to modify pod.yml file. Let me give the another name. Suppose I want to launch new pod with different pod name, right? Second pod.yml, and let me apply kubectl apply -f ctl, sorry, apply -f. Let me check the pod status, container creating. This is second pod. Yeah, it is in. Okay, it is ready for us. So if I'm trying to hit on this 10.244.0.10, I will get the same index.html page. Let's try. So minikube ssh, I can check from here directly. Curl 10.244.0.10. Yeah, this is the web page from minikube node. Okay, I can hit it from the second, and you will still get the output of index.html as well as the data file. So if I go back, minikube ssh ls mnt data, see, files are there, index.html are there, right? So this is how what we can do. We can persistent volume and take the advantages of those things. Let me remove everything. Suppose you want to remove each and everything, so you can go with kubectl delete -f. First of all, remove the pod.yml, then remove the pvc.yml, then you will remove pv.yml. Okay, deleted. Now let's check the status. So I can check the status, get pods and pv and pvc. No resource form, all clean. So guys, hopefully you understand this concept. This is very important in the term of storage, and this is the end of this demonstration part. Soon I will come up with another new interesting topic. Till then, keep practicing. If you feel something I have missed, you wanted to know more something else, please reach out through my social media link which is mentioned in the description. If you like this video, please do not forget to like, share, subscribe my channel and press the bell icon button for the latest update. Thanks for watching. Stay safe and goodbye.